Hi, everybody. Jesse Roberts, Vice President of IT Security at Compass IT Compliance. I'm here to talk about external penetration testing. We're going to do a little demo of an external pen test and, kind of what it is and what to look for. Doing this because a lot of different people have come up to me and go, well, what's involved with the external penetration test? What's your methodology? How much time does an external penetration test take? Just a whole other slew of questions, regarding external penetration test, hence this video and this short demonstration. I will say that not all external penetration tests are the same, and that's why it's kind of hard to give an answer on how long it'll take. So honestly, some of the factors that are involved are things like the amount of targets, what's open on those targets, and what other defenses might be in place, things of that nature. So every external pen test is going to be different, so it's kind of really hard for a tester, unless he's tested or she has tested the target before, to kind of know what to expect, right? So right now I'm going to start off, usually with our external penetration tests, we're given an IP to actually test off. And that might sound a little odd, like, oh, why are you giving the penetration tester an IP? Well, it comes down to, it just makes more sense for you to just give me the IP because I'm testing your security. You're trusting me. This isn't like a black hat type of scenario. This is an external penetration test with like what we would call, I guess you would say, a gray type of penetration testing, meaning that I do have some information about the target prior to testing, namely the IP. And why do we do that again? Well, it's basically to save money, right? Save time and money. Time equates directly back to money. So if you're hiring, a firm to do an external penetration test, you're going to want to just give them the IP, right? Because it's going to save you time and it's going to save you money. So, and especially when you're just doing an external penetration test to come up with some level of compliance. Maybe you're trying to do a PCI compliance penetration test, which should be done yearly, or you're just doing it to know, hey, how well is my external perimeter security really set up? So in this example here, I have a target IP of 206.198.149.233, and that is a public facing IP address. Well, how do you know that? Well, if you're not familiar with it, there's a RFC 1918 standard, right, that defines basically what private IP addresses are. So a private IP address would be something in the range of, for example, 10.0.0.0, right? That would be a private IP address. Another one would be 192.168.0.0 through 192.168.254 range, right? And then the other one would be 172.16 through 172.34. And hopefully I'm remembering those correctly. It's been so long, and that data has been sitting in my head for so long. Who knows? It's probably getting pushed out with some brain cells as I get older. But pretty much anybody in the field or has been in the field is going to be able to identify a public IP address versus a private IP address. One time I had a client give me a private IP address, and I said, I can't test this. And they're like, why not? And I said, well, because it's, impossible. Like this IP address won't be routed through the internet. So again, we'll need to know the public IP address before we get going. And this is kind of going to detail some of the steps we might do when we get an IP address to test. And again, what I show you isn't necessarily all the things we do. And, we might do more, we might do less. It really just kind of depends on the scenario presented. So one of the first things I like to do is I like to spin up a ZenMap scan. ZenMap is just a GUI front end for a product called Nmap. And Nmap is basically the premier port scanning tool. It's free too, which is great. So you could actually run this on your own network just to get a little information on things before you even have a pen test, right? The other funny thing about Nmap is a lot of these, premier vulnerability scanning engines that you pay big dollars for run Nmap in some form in the background. It's really kind of funny. So But Nmap's a free product, and kudos to the developers. I highly recommend you check out all the different switches and information you could get at nmap.org. But right now I'm going to go ahead and put in my targets. You could also input a list of IPs here. You would have to just define that in the command. The command would be, instead of putting in the IP, I would put a -il, and then I would call the path to the IPs itself. It can get a little tricky when you're typing this out. Don't use spaces in any of your file names. That's just general good computer rules of thumb anyway. Don't use spaces in file names, and it'll help you navigate a lot easier when you're using certain programs. But I don't have a list of IPs. I have one IP, and this one's 206.198.149.233. If we look at some of these other options here, T4 is for timing, meaning it's going to how fast the scan is going to go. T4 is pretty standard. If you wanted to go slower, you would reduce this number. A slower scan might give you better results. -A is going to use the most common scripts, aggressive scripts for the Nmap scan engine. -V is going to give us verbose input. Another little switch that I will usually throw in is this -PN, which by default Nmap uses a ping, right, an ICMP request to see if a host is alive. Well, for all you networking gurus out there, we all know that firewalls typically block ICMP requests by default. So if Nmap isn't configured with this switch and it tries to ping, it's going to report that, oh, hey, the host is dead. I'm not going to do any more scanning. So you go ahead and you hit that -PN, and it's going to do scanning on different ports, other methods to actually solicit information from that endpoint. Another switch that you could use, depending if you're trying to do, by default, this is going to be a somewhat stealthy scan. But if you really wanted to kind of dig in and get more information, you could throw in, whoops, I did that a little backwards. We're going to do S_T. And what that is going to do, it's going to do a TCP connect scan. That's a three-way handshake scan. The three-way handshake is, hey, I want to talk to you. Do you want to talk to me? Yeah, sure, I want to talk to you. And then the third part is, cool, let's talk, right? So that's not considered stealthy, right? Because, you're initiating communications. So, but again, with an authorized pen test, I'm not trying to be stealthy. I'm just trying to get as much information as possible from that IP. There's other switches that you could play with, and you can add in. I'll do one more once this scan is done, just to kind of highlight what's happening. But some of the things I do start off with is just this simple Nmap scan. So let's go ahead and kick that off, and let's see what we get. Oh, another note about Nmap scanning. You can't be on an encrypted VPN tunnel. When you're trying to do the scan, it'll fail out only because it doesn't know how to respond because the traffic's encrypted. So you have to have that response back. So here we go. Let's click scan and see what we get. So we can see it kicks up, and we see the -PN. All addresses will be marked up, and scan times will be slower. So as the scan kind of goes on, it's going to start reporting ports back to me. Obviously, this one has a whole lot of ports that are open, which is highly unusual for an external penetration test. So this is going to be, a juicy target with a whole bunch of different information. One of the things that I'm kind of seeing here is, well, we have port 80. Obviously, that's for web services. 3389. Remote desktop services, another, great target for hackers. Port 22, SSH service. 8080 is another form of probably an HTTP service. 3306 is a MySQL or MariaDB, so a database port's open. Again, never a good thing to have a database port open up on the internet, especially if that database isn't properly protected. Especially early versions of MySQL that allowed access with root and no password. Port 21 is going to be your FTP, so that's unencrypted FTP, I shouldn't say unsecured. Then we have a whole bunch of other ports here that really could vary. It's going to be hard for me to identify some of these. I think 9200 is VNC if I'm remembering correctly. So that again, another VNC is a remote access tool. So this target has a whole range of services that are possible for exploit. So this is where the timing comes in, right? So if this IP address hadn't really reported back anything, like if it only reported port 443 or port 80 open, that's really going to limit my attack surface, right? It's not saying that the IP is impenetrable, but it's really going to limit what I can do. Now, each one of these ports being open means that there's a service or some type of application running on these ports. So what we're going to want to do at some point is try to gather more evidence on each one of these ports. So I'll be doing that as soon as the scan finishes up. Okay, now that that scan kind of completed, it took a few minutes, so obviously it kind of paused that video, but it finished up and it started providing us with some basic information on the services that are available there. Like I was talking about earlier, MySQL. We also have, what do we got? We got 3389 kind of highlighting that's open, what the computer name it is, which is in itself, not super dangerous. For those of you that are in the field, you notice this is actually the Metasploitable 3 VM. And that VM was put out by Rapid7 just to kind of highlight their software using Metasploit. It's a cool little project if you ever get a chance to deal with it. Also note that installing it is kind of a bear, especially you have to deal with Vagrant, which is never really, in my opinion, any fun. But I digress. So we did have a couple of different services come back here. The scan finished, and it kind of reported back some results to us. It took 262 seconds roughly to scan this IP, which isn't a lot of time, right? But the time really comes in once you're done doing your scanning, your enumeration, your recon. That's when the time really comes in, when you take all this data and you start deciding on, all right, what services could potentially allow me unauthorized access to the machine. As I was saying earlier, we could get a little more information from some of these ports, and that's something I'm going to do now. Instead of using this -ST, I'm going to put in a -SV, and I'm going to also, instead of right now when I did the scan as it exists, I did it'll do the top 1,000 well-known ports, right? So it went through and it found all these ports. Well, I don't want to do that again. I want to call out specifically the ports I wanted to scan. And why do I want to do that? Well, it ends up being because the -SV is going to try to enumerate some of the data, some of the information from these services. So it's going to throw different scripts at it to get more information. So I'm going to define 80, 21, 22, 3306, 3389. What else do we got on here? 8080. And I'm going to exclude this 49156. That's most likely just a random RPC port that's open for Windows. So I'm going to ignore that one, and I'll throw in 8080 as well. And I think that'll about do it. Let's go ahead and run a scan on that. And then, like I said, it's going to actually go through and enumerate these ports to try to identify the services running on those ports a little bit better. Now, while that's going on, as a penetration test, you don't necessarily want to be sitting around. You want to be maybe looking at other sources of service. So if we kind of look into it a little bit more, one of the things that I could do is I could be looking at a site like Showdown. Now, Showdown is what's called the Internet of Things search engine. And believe it or not, this thing is out here and it's scanning your public IPs. And you're probably saying to yourself, well, I didn't really authorize that, so how can that be doing that? And it doesn't matter. You don't need to, authorize it, right? It's not illegal to do this thing, believe it or not. So it's out there, it's scanning, it's doing its thing, and there's, unfortunately, there's really nothing you do about it. There was actually a case law, and you can find out about it on the Nmap site. Maybe I could pull it up right now just to kind of highlight why, nmap.org, why scanning isn't illegal. It's definitely on here. I would just have to kind of search for it. Maybe we could do something like Nmap scanning legal, right? Let's see if that helps if you spell Nmap right. So here we go. Legal issues. Perfect. That's exactly what we're looking for. So there is a lot of different, port scanning things are funny. Sure, it's port scan. It's not a crime. So yeah, it's not. It's really not illegal. I don't think you would really have much of a case if you went up after somebody. But if you kind of read into these different cases here, it kind of highlights why an unauthorized port scan is not necessarily illegal. But also you could kind of look into some of these other cases where, people did get charged with the crime. So good rule of thumb is, unless you, an individual, have authorization to do it, don't do it, right? You definitely don't want to mess with that. Because it could just end up landing you in trouble. Especially think about this scenario where, say, you throw up Nmap and you decide, oh, I'm going to throw every single switch I have at that thing and I'm going to scan the crap out of it. Well, what happens if you end up making that service unresponsive, right? And then what are you doing? Well, you're doing a potential denial of service attack. So that's what you want to be careful of. Again, highly unlikely that might happen, but keep it in mind. So while that scan kind of finished early, and this new version didn't report back as much as I kind of wanted to. We should have seen some more information here, but that's okay. We still have enough to go on. And let me throw in the... just going to throw in an extra little SYN scan there. We'll revisit that in a moment or so. So let's review Showdown, right? So Showdown is a great source for searching on IPs. I'm not expecting this IP to be found because Showdown probably hasn't found it yet. It's a server spun up in the cloud that I just spun up, so it probably really hasn't had that much time to index. But other servers might show up depending on the IP, right? So again, Showdown is this huge repository for scanning. One of the things that we noticed in our scan was, we had a remote desktop protocol kind of show up. So it can do a search specifically like that. I'm hitting the login error, but I'll go ahead and log in with my account now. And it's not a free site. You get a limited amount of searches for free, but you could also register. And if you're in the education field, you could, and with an EDU, you get a little more than the standard user. So always good things. So let's kind of take a look at maybe the remote desktop protocol in action here. Yeah, so if we look here, so that's kind of scary, right? Oh, Microsoft Azure, somebody didn't configure their Azure site, right? Oh, hey, but wait, it's in the cloud, it should be secure. Well, yeah, but somebody also shouldn't have RDP access unlimited to this particular IP, right? You might want to limit that down to a particular subset of IPs through your Azure security group, right? Here's another one. Oh, look, administrator right available there, South Africa. So again, these are all different IPs that are just out there that it's getting scanned. And eventually, if I left my server running, I would be able to see my server pop up in here, I would imagine. But I'm not going to do that because this is just a demonstration. Let's look at some of the other things we could do. Obviously, we narrow our results down to the United States. Oh, TTCI. I don't know. Maybe TTCI. If you see this video here, you might want to call us for a free assessment. Maybe not a free assessment, but an assessment. I shouldn't say free. That's never good. But oh yeah, Windows XP. That's only been out of date for I forget when Windows XP went officially dead, but it's been a while, right? So again, tons of different information available out there. And that's part of the recon process, which again, normally, if I were a malicious user, this is one of the first sites I would pop on to see who would be a good juicy target. And again, anything that has remote desktop protocol might be a good target for me. I've already, seen tons of cases here that I could be like, hey, this is interesting. Hey, this is interesting, right? Where I could then run up a RDP scanner and just target all these from a file input. And Showdown has an API where you can do things like that, but I digress getting too much into this. But during external penetration tests, I'll definitely get my customers' IPs and I will open these, I'll search for these IPs just to see what pops up, and just again, it's going to help me identify, possible attack vectors without even doing scanning, without directly interacting with the client, right? Meaning, so this is passive reconnaissance or passive information gathering. What I was doing with that Nmap scan is actually active information gathering, where there's visibility of me hitting that IP. With this one, there's no visibility, right? I'm kind of looking at this one particular IP, Transportation Technology Center. Eco-friendly reminders, do separate. It seems like it's a waste management facility. So anyway, one of the other things that I might do, depending on the scenario, while some different scanning's kind of going on. Let me bounce back over to my Nmap scan. Yeah, a little, it might be the versioning that's going on here that it's not really identifying. Normally, I would expect to see a little more information in the version, especially since I'm throwing that SV switch in there. Not a big deal. I could really try to investigate that more, but I'm not really too worried about this case. I mean, I already know that these ports are open, and these are, high-value ports that, should be looked at a little bit further by a penetration tester. So at this point, another thing that I'd like to kind of highlight is the fact that here I was doing scanning on only one particular protocol, and that's the TCP protocol. But there's another protocol out there that's, a little bit harder to scan, only because in nature it's connectionless, right? And that would be UDP. So let me go ahead and get rid of some of these switches here, and I'm going to define the -S uppercase U switch. Keep that -A in there, keep that -PN in there, and I'm scanning. What that's going to do is it's going to scan the top UDP ports and kind of see what I have there. So some good targets for UDP. Actually, probably the best target for UDP would be port 161. Right, and that relates back to what's called the Simple Network Management Protocol. So any network device actually has the Simple Network Management Protocol installed. It might not be enabled, but it's installed. And what this Simple Network Management Protocol allows is for basically monitoring, management, updating, depending on what level it's turned on to. So it's really an amazing technology, and it's all built. It has like these little things that I call them little mini databases. They're called MIBs, and those MIBs store certain values like name, processor, transmission speed. You could even gather user names depending, again, on what's available on the server, network device, etc. So let's scan and let's see if UDP scan will give us anything. That will take a little bit of time, but we'll pause the video momentarily while that goes through, and we'll review. Okay, so while that UDP scan is wrapping up, I actually wanted to take I say actually a lot. I don't know if you guys noticed this, that you're watching the video. Hopefully you make it all the way through. I also noticed that I'm kind of getting close to the 30-minute mark with this, so I'm going to try to go a little bit quicker and wrap it up. But as the scanning's wrapping up, some of the other stuff that you kind of look for is you want to start interacting with some of the services that you already see to try to get some information on what's out there, right? Okay, so for example, we noticed that port 80 was open. So in a web browser, I'm going to open up port 80 and go after this IP, and I see this kind of weird web page here. This is actually a flag element from the capture the flag portion of the Metasploitable VM. It ends up being into a value in the view state, and if you kind of reverse this, you find out that it's a hidden image within here, and it ends up being quote unquote a flag that you want to capture. But it's still a cool activity. But in a real live penetration test, we might get a login form, some type of service. Other than that, we also noticed that port 8080 was open. This is actually another port that port 8080 led me to, but let's take a look at port 8080 first. I'm going to copy this IP. Actually, I'm sorry, I should have probably just did it right here, port 8080, and see where that takes us. Oh, interesting, Glassfish server, right? Well, what is a Glassfish server? Well, it's a simple, easy to administer web server, right? So, oh, look at that, an administration console. Well, that's what this ends up being right here. And now if I try, I'm just going to try admin password. And this is something else. This is another attack avenue that I have to look at. I wouldn't be doing the right thing if I didn't try some level of brute force on this. Or alternatively, the next thing I'm going to do is I'm going to look for vulnerabilities on Glassfish on something called ExploitDB. Now, ExploitDB is a huge repository of well-known exploits. So let's just say Glassfish and kind of see what we got. Again, there's already, I don't know how many is there, 28 different possible exploits for this, depending on the version. I obviously would have to look into each one of these to maybe help me identify what would be the best one to use. I also noticed that a couple of these have Metasploit modules. Metasploit is, again, a penetration tester's tool that has a lot of these exploits already kind of built in. So, again, that's something I would have to look up as a penetration tester to see if any of these exploits will work on the version of Glassfish Enterprise Server I'm seeing, right? I'm not going to necessarily do any of that right now, but that is certainly something that we take a look at doing a penetration test. I'll also spin up a brute forcer with well-known password lists to try to get into this Glassfish server. So I just tried admin password. Let's try admin blank. Sometimes that happens. Maybe admin. That's manual stuff. And again, I could probably accomplish this a lot quicker if I spun up a program like Medusa or Hydra to help me along with this process. But I'm not going to get there because that is something that's going to take me a while, maybe take me a while to set up. What I'm going to do is I'm going to go back to my scan data and see if that's kind of revealed anything new. If we look here, oh wow, look at this. All this different information is here. And it basically ended up being here from SNMP being open. And that's just a ton of information that's now available to me. All because somebody opened up SNMP, left it as public, which is the default password, community string they call them, for access to SNMP. There's two of them. There's public and private. Private gives you write access. Public gives you read access. But look at this down here. I now have, well, I'm going to keep scrolling. I have all these different usernames available to me. So that's going to help me. That is something I could do on, say, that web Glassfish administration console to see if I can break into that. So what I would do next is I would gather all these usernames and I would look for known password lists and I would attempt to leverage these found credentials to gain access to those services that I found. You know, Glassfish, RDP, SSH, all those different services I found. I'm going to attempt to log in with each one of these usernames. And I'm not going to do that manually. I'm going to use some type of tool, like I was saying before, to help with that process. Another thing that's kind of been going on that I haven't quite covered yet, because I wanted to make sure that the emphasis of an external penetration test is on the tester himself running different processes, tools, some inherent knowledge that the tester has about applications that might be available, because oftentimes what happens is people confuse vulnerability scanning and penetration tests. So far, I haven't really done any vulnerability scanning. Vulnerability scanning is a tool to help me identify possible exploits, ways of entries into a target IP. So I never really like to lead an external penetration test saying, oh, well, we'll do a vulnerability scan, because sometimes you could break into an application without even doing a vulnerability scan. And this is the case with this particular machine. So far, I have enough data to break into this machine, and I haven't even done a vulnerability scanning. Vulnerability scanning has not even come into play. However, part of Compass's services, and I would hope many other tester services, does include some type of vulnerability scanning. Let's take a look at those vulnerability scanning results right now. Now, I have a Metasploitable 3 scan that was already kind of done. Granted, the IP is different, and I just didn't want to do another scan of this. But if we look, 34 different vulnerabilities from the Qualys scan engine. We partner with Qualys for a lot of different scans. We also have other partners in this field, and we just try to do what's best. Qualys is a great tool, and much like all the other ones out there, they do have a great listing of vulnerabilities and exploits that are available based on the scan data. So if we kind of look into some of this, so Jenkins server, multiple security vulnerabilities. Oh, look, we have core security, core impact tool exploits available. We have Metasploit exploits available. So a whole lot of going on, a whole lot of potential exploit DBs reference, a whole lot of different methods I could try. Now, these are being listed here. That doesn't mean that it's going to be successful. It just means that, hey, the scan engine detected some indicators that that exploit will be possible. So it doesn't mean 100% that you're going to get in. Some other things that I look at and we report on are things like this TLS 1.0. To my knowledge, in the wild, nobody's actually ever exploited this TLS version 1.0, but there's a potential there, and it's also a long-term game, something that's not going to necessarily be covered by a penetration test that's done by any company. That could be leveraged by somebody that's really, again, playing the long-term game, where they'd have to position themselves as a man in the middle and then try to gather information from there. It would take a long time. Not impossible, but highly unlikely. And also here we see that it did got unauthorized users could read all SNMP information because access paths were not secure. Talked about that public. So a lot of different information here. We also have potential vulnerabilities. Again, things that the scanner keyed in on, but it couldn't 100% validate. And finally, information gathered. So not all of this information is going to be on a final penetration testing report. The only information that's going to be available on the final penetration testing report are things that I exploited directly, or things that I feel like are important for the customer, like TLS version 1.0. I wouldn't include ICMP timestamp requests because I really don't honestly know what somebody would do with that. Maybe somebody that's better than me knows. I really don't think that should be included on a report. So vulnerability scanning, while a big part of a penetration test, you don't necessarily need it. There's nothing there that says, oh, to do a penetration test, you need to do a vulnerability scan. It certainly helps, right? It certainly gives me a lot more information and possible things that I could try to do. Now, to wrap this video up, I am going to go ahead and open up one of the tools we use here at Compass. It's Core Impact. It's basically it's a nice centralized pane where I can import and manage attack data. I could import that vulnerability scan. I could conduct an Nmap scan myself right from this portal here using the Rapid Pen Test tool. And I don't start off by using this tool, right? It's a great tool, but we have to still go through the process, because if you don't follow process, if you don't follow methodology, you're not going to be successful in your engagement. So I could use Nmap, use Core Impact. I'm going to default Core Impact, pick IP version 4. And I have to define a network range. I'm going to target that 206, my IP that I have been running everything on. Add that bad boy in there, click OK. Next, we'll do a fast one because we already did a lot of legwork. We're just going to get enough information to pop it into the console here. If we have, we'll notice here we have Metasploitable 3. We have different ports that are open. A lot of those ones we identified earlier. And Core Impact will also attempt to identify vulnerabilities that could lead to exploit. Since I have vulnerable hosts right here, I could right click on this guy and do a rapid pen test attack and penetrate. And with that rapid pen test attack and penetrate, I could select my target. And one of the things within this is to launch identity modules to identify authentication weaknesses. Well, earlier I gathered a list of user names, and I am going to try to leverage that now. Also here we can attempt to deploy an agent. That's something that we do in more advanced tests where we try to do a command and control server. We won't be picking that for this engagement. And we're going to select the identity verifier attack method. We're going to do a custom attack. And I'm going to load in those usernames and passwords the usernames that I found earlier. And I'm going to load in a custom password list as well. And password lists, they're all over the internet. Check GitHub, there's tons of them out there. This one happens to be custom for this demonstration, but I can tell you right now that it does include some of the usernames in the password file. That would be very bad if a machine was configured with a password that was the same as the username. And believe it or not, it does happen. I'm going to go ahead and uncheck bunch of these options here because I don't really need these. And let's go ahead and click next. We'll do a quick one. And fingers crossed, let's see what we get. So as that runs through, we'll see a bunch of different attempts open up. And these attempts are just that. It's trying to run authentication against some of those services that we identified earlier. Oh, and look at that. We have one right off the bat. MySQL is open to root and blank password. You know what? I even think I mentioned that earlier. Older versions of MySQL have root and blank password. So that's definitely not any good, right? Let's take a look at what else we got here. See if RDP came up with anything. RDP didn't come with anything yet. FTP. Look at that. Username Vagrant, password Vagrant, definitely bad. So I now have two methods of gaining access into these particular boxes. Let's see if SSH yields us anything. Nothing as of yet with SSH. Nothing yet with RDP. But as it goes ahead and validates these identities, it's going to throw them into the Core Impact Identities tab. And if we see here, we have, oh, hey, validated yes. Oh, it looks like RDP came back with a vagrant, meaning that it can RDP into that machine using that username and password. Let's try that out. And I honestly just kind of forgot my host, but let's go back and grab that. 206.198.149.233. Let's check out that bad boy. Oh, look at that. That's good. Helps if you spell vagrant, right? And it's flashing. Hopefully, oh, look at that. That's a good sign. Come on, fingers crossed. Configuring the remote session. and boom goes the dynamite. Have access to this machine, meaning that this penetration test, this particular machine definitely fails this penetration test. Now again, this scenario is specifically set up for this demo just to kind of show what may be involved in external penetration tests. A lot of these aren't this easy, right? And this video was about 40 minutes long, a little longer than I really wanted it. But, you know, again, it's good to highlight, you know, exactly what may go on in external penetration tests. Other penetration tests may not look like this, so we can't ever really give a great estimate as to, you know, how many hours this takes. And so when it comes down to it, you're really just paying for the expertise of the tester, the tools that the company buys, and some of that knowledge and that teaming that, you know, comes with hiring a firm to do something like that. And I could tell you, Compass is probably one of the best companies out there to do this type of thing. So if you're interested in penetration testing services, I'm sure our great marketing director, Nick, will throw some links on this YouTube video, and, you know, visit our webpage. And I want to thank everybody for watching.